everybody, I'm Chris again. Going to talk a little bit about Django and some template work and how we've tried to optimize the site to deliver things a little quicker. I'm going to do a little intro, talk about some of the problems we were facing and the techniques we've tried, and then John's going to take over and get into the deep stuff with the caching and server and everything. So I am a kindergartner at Python compared to pretty much everybody here. Most of my background is in graphic design and front end. And we used to be a PHP house, and then we decided Python and Django would be better. Took us several months to migrate. Tal helped out with that, and Sean is back there. And so now we're all Python. Okay. So, let me get the presentation. Oh, error, of course. Thank you. And there we go. All right. So, how many people work, well, I'm sure a lot of you have worked with templates, but specifically more on front-end views and rendering templates, and especially in CMS frameworks. A lot of people. Okay. So at a very basic level, we create a sort of a base template, a wrapper that everything derives from. And then it gets inherited by the templates for various pages, depending on what you need. At a very simple site, you have one sort of template, and you have one main view, and it works for all your users, right? It contains all the information. The view processes the necessary variables. It's pretty simple. As far as caching, that is really, really easy. You just either put an accelerator in front of it that's managing caching by URL, or you can, in the case of Django, use Django template cache, which is a sort of inline fragment caching technique. We have tried a lot of different things. I'm going to show you a few variations at a very abstract level. I'm not going to get too deep in the code with this. So, anybody know who wrote that book? So it's from, what's his name? Philip Jose Farmer. He's a sci-fi writer. Has some really interesting stuff that goes through different times and different eras and mashes it all together, and he's really eclectic, but he just happened to have a novel called The Cache. So. Cool, so this is our homepage. This is basically this page that everybody comes to. It is, no matter who you are when you visit it, it is the same version for everybody. Really, really simple. We just do what we used to do inline Django caching with it. So we wrapped it in a template tag, specified the time, gave it an ID. That was it. And Django handled the rest. We've since moved to Varnish to do caching by URL, but it essentially does the same thing with the homepage now. There's no variation on it. It expires every 5 minutes, and then there's a few rotating images and things like that. For the most part, it doesn't change. So Bob and Ross from 2 different places, maybe one's logged in, maybe one's not. They come through, hit the homepage, it just serves it right up from the cache. So for Django template caching, got in front of the poll. Really simple, you use a time expiry. You can use it for various fragments, so you can have a few cache pieces in the same page if you want. And so you see right there, you load the cache library into the template, specify the time and the ID, and then you have your HTML in between. Pretty simple, but also pretty limited. So here's an example of a slightly more complex page. It's our browse page. We have two user levels that come to this, anonymous and logged in, and they both see different versions. So this is the logged in version. They see all the public projects. They see a message login, so you can see more. And then we have the logged in version, which gives you a wider variety of projects, shows you some things that were hidden otherwise. So we have to, this page gets hit a lot. This is the second most popular page, so we're going to have to cache the heck out of this. So we have to split it between the anonymous users and the logged in users. So before, when we were using template caching, the two users would come in, Bob, who's logged in, and Anon, who's obviously anonymous. They would hit the page, and at the template level, we would do some conditionals that would then include different template pieces based on who the user was. We could wrap that in a Django cache, and the token you give it would be either anonymous or logged in, just something unique per audience. You can use more conditionals this way. We used includes. You can get more template variation, but it's still sort of similar, or simple. We have since, John will get into this, but we've since moved to using Varnish in this as well, and we change based on a cookie that's set in the browser instead of at the template level. Okay, so this is an example of a gallery page, our most complex page in the site. Several different types of users come to this page. It changes constantly. There's lots of interaction on it. So for a front-end person, it's awesome because there's all this cool stuff going on, but caching becomes the enemy because it gets in the way of all that interaction and all that immediate dynamic content. So we have to find a compromise. So this is the anonymous version. They get a basic presentation, no specific information about the entries, and just a few options that they can do on these two buttons here. This is a logged in users version. So they get a few more options. They can see scores on some of their entries. They can see if their entries were withdrawn or changed somehow. So that's a second variation. The third variation is for the buyer, the project manager. And they have a lot more options. They see all the scores. So already you have 3 different types of audiences. And actually, for the creatives, because they're only viewing certain items particular to their entries, it's basically unique to every creative who's viewing this project. So how the heck do you cache that? If there's 200 people who are all unique viewing the page, how do you get it right for them? So the quick and dirty is you have actually 3 levels of cache depending on who it is. You're still using conditionals, you're still using includes. Now we've moved into the view level, and we're managing content differences at the view level. And we get conditional madness going on down here. So we tried using just regular template cache, doesn't really work, because as soon as something changes, the audience, whoever's viewing it, won't see it until it expires. We tried using just simple varnish by URL. That won't work because the URL is the same for everybody. So we tried for a while just using Ajax to change JavaScript calls to change the contents dynamically. But the advantage to caching is that the request doesn't go all the way through, right? So you don't hit the server. It doesn't have to process anything. It's simple. If you're making all these Ajax calls afterwards, you lose the performance you get with a cached page. Yeah?
So if that page is changing all the time, why do you want to cache it well? Is it like in a given instance, like 300 people might be looking at that particular thing, and then 2 seconds later do something else, so when you cache something that expires in a few seconds, kind of thing? Okay.
Part of it is performance management. So if the view that renders that particular page is really complex, it does a lot of sorting on the queries. Lots of different variation in terms of permissions that are in there. So the manager of a project could come in and is allowed to do certain things, whereas a creative can't. Anonymous has very little. So there's a whole lot of interlocking pieces. So it really slows down. So you have to do some sort of level of caching to try to help speed it up. So what do we do now? What's the next step? More servers? We tried that. What's that?
Edge, I forget what's called, edge side caching.
Yes. So good point. John is actually going to get into something directly related to that. So we had a few options on the table. We obviously already had Varnish in place, so we can try to leverage that. We can try to do some more view level management, but again, we don't want to hit the views every time so that the server can spit it out faster. So we have to use the tools we have at the moment and then figure out a proper solution. So what now? With that, John, are you ready? Any questions so far about this? I do have specific examples if you want to see them afterwards for particular solutions. Yeah?
Is the slide with Bob and Ross really the Bobs?
No. Well, I guess Ross could be. Okay, you ready, John?
You got it.
I don't like that. Thank you, Chris, for handing me the hard job here. My name is John. I'm a backend developer here, and welcome again. So Chris has done a lot of setting up the stage for me, but just bear with me a little bit. I'll actually do just a little bit, tiny bit more of the setting up the stage. So yeah, cache everything using Varnish, and Varnish is, what I mean is not the one you can buy from a paint section in Home Depot, but actually just do a quick survey. How many of you heard of or actually use Varnish? Okay, so quite a few people. You actually use that in production?
I just play with it.
All right, so give me a little idea of, let me actually get into it. So what is Varnish? It's basically an upstream cache, HTTP accelerator. Also, it's a load balancer, and we use Varnish for all of those features here at Crossbrink. And one of the things I'll get into today, which is really nice about it, is the X-side scripting. It's the ESI, and I'll get into that a little later after I set the stage. It's very fast. It's open source, and it's got its own scripting language called VCL, and it's very flexible and configurable. Compared to Apache, where you do its own mods and all that stuff. So with Varnish, you can just basically script your situations. I'll get into that a bit more later. So the usual concerns with caching, as Chris has mentioned, the very first one is how do you so you can cache anonymous users pretty readily because they don't change very often. How do you deal with permissions? How can you cache a page that's got members logged in, it's got personal data on it? Cache duration. How do you judge really easily whether a page deserves 2-minute caching time or 5-minute? And caching fragment. How could you more efficiently cache different parts of a site that changes using having different durations. You could have a section of a page that changes in real time, but other parts don't change almost in a day. So how can you be more efficient in that? So here's going to be a little bit of my stage. So the usual task is very common in really any of your projects. The task is you have a collection of things, and whether it be photos or videos or images. In our case, we show a lot of images for creatives that upload entries to our projects. as well as PDFs and text, actually just raw text. So how do you show all that stuff to the users and make it fast? So here's what we do. Like basically, Chris set up some of that. Thank you very much. But our gallery page basically it shows potentially ranging from 1 or 2 images to up to 1,000 entries for one project. So how do you essentially with this page that varies based on whether the user is anonymous or logged in, and based on whether the user has different kind of level of permissions. That's really when I was doing my presentation. That's really kind of my make your boss happy promo for PowerScreen, but Chris has done so much of it that it's no longer a surprise. So I decided to just throw my boss's picture on there to sort of end up the level. And I think when you do that, you either really like your boss or you don't like them. And I assure you that for my case is the former. So so that's that. I want to talk about a little bit about human evolution. So if you're a caveman, when you look to solve that problem, you have entries that you want to show in a gallery. You probably come up with things. You grab each one from a collection and you process it, and you show that linearly. And so then the caveman here dresses up a little and grabs a stick and finds out it's still linear. Dumb joke. So then now, fast forward 100 years, and if you look past the nudity here, and if you're aware of Django's paginator, how many of you have heard of paginator? So the runtime of your page becomes the number of your entries divided by the number of pages, right? Because you don't want to grab all the entries that, you just want to grab the entries that people see on a specific page. So that's good, but we want to do a little better because humans need to improve and all that. So here is the next step here, as we got kind of fat and we're comfortable, we don't want to work so much. So but we still want our websites to be fast. So we want to figure out a way to basically make the page that you have seen in the gallery page run in constant time. So so here's another level of my stage setting, and it's going to get into really now the guts of it. So ESI, what is ESI? It's in plain terms, it's kind of a content substitution. It is built into Varnish. It is kind of basically Varnish's templating language. So essentially, it's pretty simple. If you have a response from, let's say you use Django or you use any kind of web server, and the response gets back to Varnish and is ready to be processed back to the user, the Varnish basically scans the content of the response and look for patterns. Is there any includes? Includes that point to other URLs, and if there are, no matter how many, it could be 2 or 3 or however many fragments you have in your page. Varnish actually will basically sort of pause on passing back the response to the user. It would instead basically grab, kind of asynchronously grab all these contents from these includes and gather back the results, sew them together, and then return back to the user. And one nice thing about this, since Varnish is a cache, cache in itself, you can selectively cache any of these fragments in these includes, or you can elect not to basically cache them. So if there's a URL that's more dynamic, you can have it be grabbed every time. And if there's something that's cached 10 minutes versus an hour, you can do so as well via its scripting language. So here's, I'm going to get into sort of this, the diagram that really gets you to understand what actually it does underneath the hood. So basically, you have a browser, you have a user, and it's requesting, give me some stuff in this path, slash stuff, the URL, and it could be, in this case, our gallery. And Varnish, in the next step, passes that to Django, in this case, asking for the real content because it's not already in the cache. Django then does a couple of things, and it's good to be careful here with the runtime of all these, because so the first thing that it does is check for permission. At the time that the Varnish passes the request to the Django, it has all the cookies and the session data, and is able to decide whether the users can see anything or not, or which things the user is able to see, and that's running constant time. As well as it'll decide at that time to generate a hash key. And I'll kind of explain that later. But if you see the yellow big arrow here pointing back, it's basically generating a template with 2 includes. And here there are 2 includes just because I don't have much space in the screen, but you can have as many includes as you want. And so in here, if you pay attention, it's basically you have a part 1, part including the path, the user type, as well as the secret hash, and another part. And then Varnish sees this template and basically says, okay, so you want me to fire back another request back to Django and grab these content. And this can happen in parallel, by the way, which would be a nice thing to have. So at this time, each of the Django nodes verifies that hash, that secret hash, and basically authenticates that this is a legitimate request. And according to the type, the user type, and the fact that it's authenticated, generate the data. And this is, by the way, the first request that has hit for this URL. So what happens next? When these 2 Django instances on the right bottom returns the response, Varnish then at first caches the response for each of these URL, and this URL is basically the bottom where the user type and secret hash is cached. Basically, the path of the URL is the key that's cached in Varnish. And it also does, in addition to that, sews up the response of these two additional requests together. And it's interesting to know, while this is all happening, the user is still waiting for this, for the request. The user has not received anything yet. After it does that, it returns whatever the user actually requested. So this is what happens on the first read, if you will. And if you notice, this is still running in linear time because it goes over. Maybe the part 2 is the part where actually it generates the list of images on the gallery. But what actually is going to be interesting is on subsequent requests. Hang on a second. I didn't have that slide. But on subsequent requests, when Varnish hands over the first request to Django, it still would do the check permissions and it would generate the hash. But next time, as long as the permission is checked and it's authenticated, Varnish already has the content that later Django, the other 2 Django nodes returned. So essentially, that becomes a constant time request. But it's also good to know that it's a constant time request, but for each request, it does also check for permission and all that dynamic things that you want to do. So, here there's an interesting thing to know because where does that hash come from? When does that hash change? And that depends on your application because in our application, you have to control when the invalidation of the cache happens by changing the hash when, for example, a user uploads another image to the gallery. Or when, for example, maybe in our case, the buyer can score an entry or even change the title of an entry, things like that. So that's come with the cost of you do have to handle the invalidation of the cache key. So to summarize, basically, the common case of this is you have basically constant time read. The worst time for the user to have for the writing time is linear for the first request. And assuming your application have a ratio of n versus 1 reads versus writes, you have an amortized constant time of your average case read. And that's how we do our gallery currently. I think that's it. Any questions?
Do you cache parts of post requests?
No, we don't do any post.
Don't do any post.
We don't do any post caching.
Oh.
Did you use anything to help you with the varnish outside of varnish itself?
We actually have Nginx in front of Varnish, but mostly to handle secure SSL.
Are you running Varnish in development, or do you have some sort of tool that to do normal development and then only do Varnish stuff in production?
Yeah, that's a great question. We have a Django tag that we write. Basically, when you have a setting that's in development mode, it basically just does everything in Django templating instead of Varnish, so it's not required.
Is that something you guys wrote, or something that's open source? Or?
It's something we wrote, yeah.
So what do the views and templates kind of look like with the system? Just to kind of give us it might not be a slide, but like a visual of what.
I don't think we're set up to show any code. You can? Okay.
You can just kind of explain where each, like the views and the templates, are these things happening, or?
Is there a specific part in the flow that you want to see?
Like when it generates the hash, or when like back and forth, like, where is that occurring?
So I'll try to answer that question without code as much as I can. So basically at the top right corner where the request first hits Django, all the content it needs to return is really those two lines. When Varnish actually sees those two lines, it basically it makes another two requests to retrieve that from Django. And so if you're talking about sort of what would the template include for that first step, it's there right there. However many parts you have, put that in your template, give that to Varnish. When Varnish gets each of those URL, your template basically will do the same with Django templates. You need to generate the content for part one. Let's say part one is your header, part two is your body, and you could have a part three to be your footer. One of the nice things with this setup is it forces you to be modular. You have to write your code to handle these fragments separately instead of having a whole mess. But to really answer your question, it really does not dictate any new ways you have to program your templates or your views. So it's pretty much the same. It's just a regular Django view that takes a request and return a response. Does that kind of answer your question? Yeah.
So I guess like in Django, like you were just writing, your simple, here's my application, and you had like 3 different tables of data on there. You'd probably like be passing 3 collections of queries or whatnot into your template. Instead, you guys are basically just putting in 3 aside includes, and then each of those is a separate view that only does one small little query and returns just that bit. It's basically.
That's basically it. Yes. It basically helps with a couple of things. It helps with permission because we do want permissions to be checked on every request. We may not want really to care for anonymous users, but for logged in users, we do want that to happen. And we want the cache to last as long as possible until the next write. And this allows us to basically do that. And Varnish basically, as the next write happens, you change your hash key. In our case, actually, it's a freshness date. When the user updates something, we change the timestamp. And that timestamp leads to a new generated hash that basically gets cached in Varnish as a different key.
You don't actually invalidate, you just, the whole key changes, so then it's not in the cache.
All we do is invalidate the Django, the backend object that generates the hash. Varnish, we just let the Varnish cache go stale. You know, if it fills up, it'll throw the ones that are not being hit, and that's all we do.
Not to give you a hard time, but I noticed that your website was completely dead for at least 20 minutes this afternoon. I was wondering.
My fault. Something that's a lesson for I guess for all of you. When we got our domain, we registered in GoDaddy back in 2006 when we were just thinking about startups, and we're using their DNS service, and it was pretty reliable. They recently came out with a premium DNS service, and as a marketing push to try to get people to convert, they started throttling their DNS servers a couple days ago. So a couple days ago at night, our servers crashed. Tonight, our servers crashed, and all of a sudden throughout the day, nobody could reach us. And when we found out it was a DNS issue, it was an oh shit moment for us. So in the middle of the day, we decided to move DNS. Not the best thing to do. Lucky, we had the TTL set very low. So we moved them, but one of us, me, in moving the DNS forgot all the CNAME records. And so, so that caused a little bit of a hiccup. The good thing, there was only a 10-minute TTL on the DNS, so we got it fixed. But the reason it was down is because I forgot all the CNAME records. Wasn't caching or Varnish. I tried to blame them all.
Any questions? Okay.